All right, this is 2.7 logical arguments, evaluating arguments. Now this is going to be a very long section, so there's going to be several videos in this. So I'm just letting you know up front. So let's just focus for right now on what a logical argument is. A logical argument is a claim that a set of premises supports a conclusion. There are two general types of arguments, one of which being inductive and deductive. I'm sure you guys have heard of inductive reasoning and deductive reasoning. But an inductive argument uses a collection of specific examples as its premises and uses them to propose a general conclusion, whereas a deductive argument uses a collection of general statements as its premises and uses them to propose a specific situation as a conclusion. We are going to be evaluating deductive arguments. So a deductive argument is considered valid if, assuming that all premises are true, the conclusion following logically from those premises is also true. In other words, when the premises are all true, the conclusion has to be true. Now this is going to be very important. Okay? So again, the premises have to be true with a true conclusion. Can we have a valid argument with a false conclusion? And the answer to that is absolutely not. Okay, so again, the premises have to be true with a true conclusion. Okay, so there are two ways to evaluate deductive arguments, one of which is through a truth table, so we'll look at that. And then the other one is by using common arguments. Okay, when we get there, I'm going to show you that the common argument page, the definitions will be given to you, so you don't have to memorize those. But truth tables, you do need how to figure out how to use that. Okay. So, by the way, the truth tables are usually used with the conditional disjunction and conjunction, okay? So let's check out the deductive argument with the truth tables. So we're going to represent each premises and the conclusion symbolically. Then we're going to create a truth table for the statements, and we're going to label columns that are premises and columns that are conclusions. If this is a tautology, which is always true, then the argument is valid. Otherwise, it's an invalid argument. So what they mean is, like for instance, if I have premises 1 and premises 2, and I have a conclusion, which I'm going to write the therefore symbol, this is conclusion. P1 has to be true, P2 has to be true, and the conclusion has to be true. Okay? If P1, which is premises 1, if P2, which is premises 2, and I have a conclusion, if P1 is true and P2 is true, and I have a false conclusion, then the whole thing is invalid. Okay? If, and I'm just going to give you another example, P1, we have P2, and then conclusion. If I have P1 is false, P2 is true, and then I have some random conclusion, it doesn't matter because you have a false premises, so we don't even look at it. This is going to be invalid. Okay? All right, so hopefully that clears the air a little bit. Let's go ahead and look at some examples. Determine whether the arguments are valid or invalid. Okay, so when you get this, you got to read through it, and you got to write everything out symbolically, okay? So let's check it out. If water is frozen, then its temperature is below 32 degrees Fahrenheit. This water's temperature is not below 32 degrees Fahrenheit, therefore this water is not frozen. So let's figure out what is P and what is Q. So we have two things going on. Water is frozen. And then we also have Q, its temperature. I shouldn't have wrote that. Its temperature is below 32 degrees Fahrenheit. Okay? All right, so let's do this line by line. Line number 1 is going to be premises 1. If water is frozen, P, then its temperature is below 32 degrees Fahrenheit, Q. So we have the conditional. Again, this is premises 1. Second line. This water's temperature is not below 32 degrees Fahrenheit. This is premises 2. So I write this up as this water's temperature is not below 32 degrees. So that is going to be negation Q. Premises 2. Okay. Then after the premises, you have the word in the next sentence, therefore. Therefore is your conclusion. Okay, so I'm going to write that up as, it looks like a triangle, like 3 dots there. Whatever comes after that is the conclusion. This water is not frozen, so this is negation P. Okay, so the first step is done. I figured out what premises 1 is, premises 2 is, and the conclusion symbolically. Now I have to make a truth table. Okay, so I have 2 things, P and Q. I know I'm going to have 4 rows. And I'm going to write this out. Premises 1, I'm going to put a little note here. Premises 1 is if P then Q. Okay, premises 2 is negation Q. And then my conclusion is negation P. All right, guys. Again, 4 rows. And I know this because I have 2 letters P and Q. Okay, so 1 row, 2 rows, 3 rows, and 4 rows. Okay. All right, so P is true, true, false, false. And Q is true, false, true, false. So I'm doing if then. Remember, it's a conditional. So if true, and I'm going to write down all of P, true, true, false, false. Write down the symbol, and then write down all of Q, which is true, false, true, false. And then analyze. Remember, it's the conditional. The only time the conditional is false is when you start with something true and you back it up with something false, which happens in row 2. Otherwise, the rest of them are true. So row number 1, if true, then true is true. Row number 3, if false, then true is true. And row number 4, if false, then false is true. Okay, so premises 1 is true, false, true, true. Premises 2 is negation Q. So I'm going to negate true to get false. I'm going to negate false to get true. I'm going to negate true to get false. And I'm going to negate false to get true. And finally, I'm then going to negate the P column, which is negation of true is false. Negation of true is false. Negation of false is true. Negation of false is true. Okay, so let's put pieces together, right? I'm going to do P1, P2, conclusion. So all I'm going to do is copy those down again, just for clarity, so that way you can see how I do this. Okay. Again, 4 rows. Okay, 1, 2, 3, and 4. All right, so P1 was true, false, true, true. I'm going to write that down. True, false, true, true. Okay, P2 is false, true, false, true. And conclusion is false, false, true, true. Okay, so now here is when we check the premises. If you have a false premise in either P1 or P2, I'm going to strike out the entire row because I don't even want to consider it. Okay, so let's look at row 1. P1 is true and P2 is false. I don't care what the conclusion is, get rid of the row because we're not considering that case. Case number 2, P1 is false and P2 is true. So again, if I see a false anywhere, I cross out the entire row. In case 3, P1 is true and P2 is false. So again, if you find a false, cross out the row. And finally, In row 4, P1 is true and P2 is true. Now we have to check the conclusion. If the conclusion is also true, then the whole entire thing is valid, and that happens in this case. 2 true premises with a conclusion that is true is valid. Okay, so that's how you do these. All right, I'm going to do one more and then we're going to stop the video and restart up again. If you get up at 6 a.m., then you will go to the gym today. You do not get up at 6 a.m., therefore you did not go to the gym today. So there's 2 things going on. P, you get up at 6 a.m. And Q is you will go to the gym today. Okay, so again, line 1 will be premises 1. If you get up at 6 a.m., P, then you will go to the gym today. If P, then Q. So that is the conditional, and that is premises 1. Now let's look at line number 2. You do not get up at 6 a.m. That is negation P. So that is my premises 2. Now the next line says therefore, so I know that's my conclusion. And whatever falls after therefore is the conclusion. You did not go to the gym today. So you did not go to the gym today is negation Q. Okay, truth table time. I only have 2 letters, so I'm going to have 4 rows. P, Q. If P, then Q. Negation P. And negation Q. Okay, and let's label if P, then Q is premises 1, negation P is premises 2, and the conclusion is negation Q. Whoa, that was super crooked. Okay, so again, 4 rows. 1, 2, 3, and 4. Okay, P is true, true, false, false. Q is true, false, true, false. Again, write down P, true, true, false, false, with the conditional sign. And then write down Q, true, false, true, false. Again, for the conditional, the only time it is false is when you start with something true and you back it up with something false that happens in row 2. So this is false. In row 1, if true then true is true. In row 3, if false then true is true. And if false then false is true. Okay, so I have P1 done. So I'm going to use this later, true, false, true, true. Now I'm going to negate the P column. Remember the P column was true, true, false, false. So I'm going to write down false, false, true, true. And negation of Q is true, false, true, false. So I get false, true, false, true. Okay, so I'm going to use the negation P column and the negation Q column. So I'm going to write this out. Premises 1. Premises 2. And you know what? That line's bothering me. I'm going to redo that. It just looks super crooked. Okay, so I'm going to redo that real quick. And then conclusion. Okay, so again we have 4 rows. 1, 2, 3, and 4. Okay, so I'm copying down what I got for premises 1, which was true, false, true, true. I'm copying down what I got for P2, which was false, false, true, true. And finally, conclusion was false, true, false, true. Okay, so look at row number 1. I have a false conclusion in P2, so I'm going to strike out that entire row. In row 2, I have 2 false premises, so I'm going to get rid of it. In row 3, I'm okay because I have true, true for premises 1 and premises 2. So we're going to keep that. So far, so good. But we have to look at the conclusion. And row 4 is the same thing. Okay. So row 4 is fine because I have true premises with a true conclusion. However, in row number 3, I have 2 true premises with a false conclusion. So if that happens anywhere in your truth table, the whole thing becomes invalid. Okay, it doesn't matter that row 4 is, it looks like it's valid. If you get true, true with a false conclusion, the whole thing becomes invalid. All right, we're going to stop here. I'm going to pick up with part 3. So we have 2.7 part 3 coming up.